Okay. I'm starting just a little bit early so that we're testing the microphone right now. See how that goes. Yeah, I still got 1 minute before 2 o'clock. Testing 1, 2, 3, 4. Testing 1, 2, 3, 4. Testing 1, 2, 3, 4. Is my microphone seem to be working right yet? It shows on my monitor that it's working. I have audio, says Carlos. Cool. All right, we're going to give it like another 30 seconds. Hey, we got Randy here too. I'm checking the monitor over here. Newtons per second. Awesome. It's 2 o'clock. We can start. Welcome to RockSim Live. I am Tim Van Milligan. I am your host. This is where we talk about using the RockSim software and how to make it do things that it wasn't designed to do. Yeah, so if you are watching today live, we have the comments going on, and you can put in the comments your name and where you're watching from. We just kind of like to recognize that you're here. We really appreciate it. So as you come in, say hello, and I'll call you out. We have Johan, we have Carlos, Randy, Newtons per second, D. Degoo, Kevin's Models and More. Cool. Johan writes, for fun, you could just move your lips. Johan's got a sense of humor. Okay, so if you are watching this for the first time, what is RockSim? So let me bring up my screen here. And RockSim is a product of Apogee Components. Let me get a little bit here. On our website is apogeerockets.com. We are doing the RockSim training live right now, and that's here on the screen. And if you want to learn RockSim or download the free trial, go to How To and Guides here at the top. Come over down to the side to software. And then in software, you can download the free trial right here. We have video tutorials over here. We have lots of other information, and we have the RockSim Live training, which is what we're doing right now. And if you go to this page, this is where we have all the previous archives of all the previous episodes since we started last year in 2021. We need to change the date here. It's 2022. Yeah, so like we're on episode 59, and we are March through 4, I think it's the 4th, 2022, and we'll have a link to this episode here on this page, and then these are the topics that we talk about, and these numbers here to the side are, when you go to YouTube to watch it, that's the timestamp. So if you just take the scrubber bar and you just slide it along the screen to the, like to the 7 minutes, 20 seconds, you'll find big news with the launch visualizer. Yeah, we had some big news last week. We released some cool things. There's like little changes that are happening, and we're making it better. And it's kind of like we sneak them out there to people. So so try out that launch visualizer. The launch visualizer works with RockSim. So you take your RockSim design and you want to see it in real life, what it's going to look like flying from your launch site, and how the wind's going to affect it. If you got a wind coming from the west, where is it going to take it? What's over there in the east where the wind is going to make your rocket drift? You can look at the launch visualizer, and it tells you all that information. It also shows you the trajectory, where it's going to come down, how the rocket's going to spin, pitch, and yaw as it reacts to the wind. That's stuff that RockSim doesn't do. So, you know, this is like an add-on for RockSim to make it even better. And, you know, if you go to the Apogee website, we put all of our rockets into the launch visualizer, all the Apogee Dynastar rockets. So, for example, if I type in, this one here is the Sky Torpedo. Oh, you're not seeing it. The Sky Torpedo. This is one of our kits on our website. If I type that into the search bar, and you just start typing, and there it is, and you click on that. And then you scroll down on the page, and I'm just going to scroll down past this to right here. See what your Sky Torpedo rocket will look like flying from your field. This is a widget, but it opens up the launch visualizer. So if you just click on that, it's going to load the launch visualizer with this rocket already preloaded. So if I just scroll down, look, there's the rocket sitting on the launch pad. Now, you're thinking, well, this doesn't look like my field. Well, this is just the orientation of the rocket, so you can kind of see it. When you start and do a launch, in the launch button, here's the one thing that we're still working on to fix. The launch button is right here, but if you scroll, you see how it kind of gets hidden. We're going to fix that. And if you want this screen to be bigger with this rocket in it, just click on the launch visualizer icon right here. And what it does is it opens up the launch visualizer in a new tab. And again, the same rocket sitting on the pad out over here. And you can, you know, select where you're going to launch from. I'm not logged in right now because otherwise I could see the entire Earth. And all these are locked until you log in. You know, so if I log in, I would go up here, you know, and do my my login. Hopefully this will work. Yep, there. Now I'm logged in. The unfortunate thing was once you log in, it takes that rocket and it clears it out. I think. Yeah, it gives me a different rocket. Ooh, that's interesting. So then what I would do, I would close that tab, just come back over here, click on it again, and it relaunches the launch visualizer. And now this time I'm logged in. See, I'm logged in under my account right here, and I'm a premium member. So for me, all the things that were locked are unlocked. And then right here is, this is the Earth, and this is the current launch site. This is my launch site in Pueblo, Colorado. But you know, you might be somewhere else in the United States or the rest of the world, and you can just, you know, all these are pre-existing launch sites for NAR and Tripoli. The NAR are the red ones, Tripoli is the blue ones. And you can launch anywhere you want, including places that aren't, you know, regular launch sites. Say you own some property here. I'm trying to find a nice green grassy area. So like right there, if you double click on it, that's my new launch site, and then it confirmed the launch site, and I can go ahead and launch that rocket. So that's how the launch visualizer works. That was the new news last week. We added the launch visualizer here to automatically launch that, which is cool. And we've already made some changes to it. And, you know, we're just making it better and better. Now, that's the beauty of cloud software, is you can make changes and it goes out immediately for everybody. So everybody gets the benefit, and you don't have to wait for us to fix bugs and, you know, send out a file that you have to download and then install on your computer. It all happens automatically, and it's just awesome. Okay, so I'm going to check the comments here, see if we got any RockSim questions. If you have a question, go ahead and type it in, and I'll try to answer it. I do have like a couple that came in via email, so if nobody has a question, I'll answer those. Newtons per second says, hello, he's Josh from Massachusetts. Guy Chemo, quick question, does RockSim use the upper or lower rail button in calculating the speed when the rocket leaves the rail? Okay, that's a good question. So let's close that. So here's a design that somebody sent me. This was one of the ones that I wanted to talk about. Let me open I'm going to just go to RockSim Pro, open up a new design in RockSim Pro. So here is my file open. This is a V2 or an A4 rocket. That's interesting. I got some kind of remnant here on the bottom of the fins. I don't know what that is. That wasn't there the other day. Does this rocket have a launch lug on it? Okay, so this one has two. It has one right here. Oops, cancel. And one right there. So he's asking the question, when you do a flight simulation, like this one right here, you get this velocity at launch guide departure. So the rocket has to travel, and on this rocket we probably had either a 3-foot or 4-foot launch rod. It was probably a 3-foot rod, and he was asking, RockSim uses the launch guide length, and does it use the upper or lower launch lug? And the answer is it doesn't use either. It uses the distance that the rocket travels. So it assumes that it's going to be the lower launch lug, but there's, say you have a 36-inch rod. Let me go here to wide angle. So you got a 36-inch launch rod going up through your launch lug. So the pad is right here, so that's where the 36 inches starts, from right here, and then it goes up here. RockSim uses 36 inches, so it's like the rocket shifted down a little bit on the launch pad. So, or there's more length on the top. So it's going to travel 36 inches. So you got to assume that that's where it is. It's going to be technically the bottom one. But it's more looking for the distance traveled, not so much where that launch lug is located, which can be kind of confusing because where you put your launch lug does matter. So that's a good question. We have Randy from Memphis, Tennessee. We have Sam from Abilene, Texas. Johan says, I can come up with an immediate question. Can you create your own motor with the characteristics that are known but not in the database? For instance, an E motor with 39 newton seconds, or 39 newton seconds of total power, 30 newton seconds peak, 20 newton seconds average, and a 2-second burn time. The answer, Johan, is yes. But you don't do it within RockSim. You have to create an engine file and put it into RockSim. So that's a really good question. So let's do one. What I'm looking for here on the bottom of my screen, and I don't think you can see it. I better show my screen. Okay, so I'm going to have to go to my applications folder. Okay, so here's the contents of my applications folder, and I've got RockSim 10.3. I'm looking for the last one. I think this was the last one, 10.20. See, I have multiple versions of RockSim on my computer, including some beta test versions. Because we're always fixing things, always adding new things, and those things are coming, which is going to be really cool. Okay, so I'm going to go, this one's pretty old. This one's from June 25, so that's probably the last one. So I'm going to open that one up, and then inside your applications folder of RockSim, there's a program called Engine Edit. And that is where you create rocket motor files. So I'm going to launch Engine Edit, and it comes bundled with RockSim, so you don't have to download any other software. It's, if you downloaded RockSim already, or the free trial, it's on the free trial too. Engine Edit is there. So this is the start of Engine Edit, and to create a rocket motor, we're going to click right here where it says Add New Engine. So here is where we're going to start putting in the parameters that he wanted. So he's got a 2-second burn time, is what he said, 2 seconds, and a peak thrust of 30 newtons. So I'm going to put that in there and click OK. And you can see it created a graph. And off here is 2 seconds. And so we can just start drawing a thrust curve. So he wants a 20 newton second average thrust with 39 newton seconds total of total power. Okay, so the total impulse is going to be 39. So when we create our thrust curve, it's going to have to be right here. And the average thrust is going to be right here. So we got to make this one 20 and this one 39, and the burn time is going to be 2. So what you do is you just start clicking on the graph. Okay, so I got this is a thrust curve, and we've got an average thrust of 16, and a total impulse of 33. So man, we're already at pretty high. So what I'm going to do is I need a peak thrust of about 39 newton seconds. I clicked too many points there. They're too close together. So that's pretty close to 39. So we have a 38.993. Total impulse of 31. Average thrust of 15. Okay, so we can, oops, I wanted to drag that point. Okay, so total impulse is 42. Okay, so that's good. This is pretty good. We hit the low, oops. I keep adding points where I don't want to add points. So if you want to get rid of some of those points, you got to go to View and go to Time Order Data. And click on that. And so here is the data points. And let's see, this is going to be about 0.2527. This one right here is that third point. And I'll just hit delete. Okay. And I can click and drag that one. So what I'm looking for is average thrust of 20, and this one is too high. I got to get that down to 39 newtons a second. So what I'm going to do is just going to lower this one and lower that one, 38.933. Okay, so that's pretty close to what Johan wanted. Okay, so I'm going to make this, you can say unknown, which is totally fine, or you can pick a different manufacturer. There's a lot of old manufacturers here in the database. A lot of these manufacturers are long gone. Let's just say, we'll say unknown. Okay, so this is going to be an E motor. So it's going to be an E. How do we know it's an E? Because this is where you look at the NAR motor classification. So anything that has more than 20 newton seconds up to 40 newton seconds is an E motor. So an A, I always start with a C motor because a C motor is 10 newton seconds. So you double that, it's a D, so that's 20. So a D motor is anything from 10 to 20. And then an E is 20 to 40, and we're at 39.678. So this is going to be an E, so it's going to be an E. And then the second letter is the average thrust. So we can tweak things and make it exactly 20. Oop, I did that again. This time ordered data, it's right here. You can also change the data points in here. Let's make this 33. Hit tab. 39.989. We're so close. I'll just leave it like that. Oops, wrong one. Go away. Time thrust data. Okay, that's the one I wanted to go away. Okay, so here's our thrust curve. So it's going to be an E. We'll call it an E20. And engine type. Okay, so we'll say it's single use. It's not a reloadable. And then ejection delays. So this is where you can add in your ejection delays. So 0 is a booster motor. Say this is a black powder, so a 0. Maybe it's going to have a 3, 5, 7, and maybe a plugged motor. So I can go, you use a comma in here, so you go comma 3, comma 5, comma 7, and then comma P for plugged. Plugged motor means there's no ejection charge. So it'll burn out, and then it's not going to pop out a parachute because there's nothing to push it out. So that's a plugged motor. And then you have to start putting in your diameter. We'll call it a 24 millimeter. And the length, how long is it going to be? We'll call it 95 millimeters. And then it's important to give it initial mass and propellant mass. And I'm going to cheat and see what an Estes motor is. So I'm going to go to an E16. E16. I'm looking, okay, so here's an Estes E16. And what I'm looking for is total mass right here, and then propellant mass right here. So it's 81 and 40. This one had a length. This was a 29 millimeter. Well, let me let's see. What's an E12? Estes has an E12. Okay, so here's an E12-4. This is probably a better thing. Okay, so 95 millimeters long, which is what I guessed at the length. Total mass of 58.5 and a propellant mass of 35.9. So I'm just going to slide that off to the side here so I can see it, just in case I need to see it again. Okay, so, uh-oh. I think I just froze up. Why is it frozen up? Ah! Yeah, that's not good. That's the spinny ball right there. Never a good sign. Yeah, I'm locked out of it, so I got to force quit. Yeah, it says engine editor not responding. Wait a minute, let's cancel that. I want to grab a screenshot of this. So there's my screenshot. So I'm grabbing a screenshot right here, just so I can duplicate this quickly, because I got to duplicate it. Okay, so recent items, engine edit. Okay, let's see how fast I can do it now. 2 seconds, peak thrust, 39. I screwed up. I said 0.002. Let's try that again. File new. No. Peak burn time, 2 seconds, 39. Okay, that's better. Okay, so now we're over. So we gotta bring that down just a little bit, because if we're over 40 Newton seconds, then we're into an F motor, and we don't want to make an F motor. We want to make an E motor. Okay, so now we're there. Okay, so unknown, engine code E20, engine type single use, ejection delay 0, 3, 5, 7, diameter 24, length 95 millimeters, initial mass. That says 58.5, propellant mass 35.9. Okay. Okay, so now we need to save this file. So I'm going to go File, Save As. Where am I going to put it? I'm going to put it on my desktop. I'm going to call it an E20 RockSim Live RSL, and we're gonna use the engine. We want to make it the RockSim format. It doesn't really matter. Engine edit. ENG is the old format. RSE is the new format. RSE stores more information. For example, it will store the fact that it is a single-use motor. So if you're in RockSim and you only want to see single-use motors, that's how you do it. It saves that information. So I'm going to hit Save. Okay, so now it's saved on my desktop, and now I've got to get that motor into RockSim. So, so here I'm back into, no, that's RockSim Pro. That's okay. I can do RockSim Pro. Doesn't matter. It's identical in RockSim and RockSim Pro. So what I'm going to do is from the File menu, let's choose Import Engine Files. And now we need to find where that file is that we just created. And I put it on my desktop. And it's right here, E20-RSL for RockSimLive.RSE. So we'll select that and click Open. And we get a message saying that it is, it copied that motor file and it moved it into this folder right here. So Application Support, Apogee Components, RockSim Pro 3, Data. So this folder, that's where the default location is. It's a hidden folder, so it's really hard to find, but at this point you don't have to worry about it. RockSim will just put it in there automatically. So click OK. And then what it does, it brings up this screen, and this is where it shows all the existing motors that are currently in RockSim, and then plus all the new motors that it sees in that folder, this folder right here, but that are not currently associated with RockSim. So we need to associate this motor into RockSim, so we'll select it and then click Add. And it added it right here. And then click OK. So now let's see if we can run a simulation with that motor. So here's the rocket. This is a 24 millimeter. So this will work out really well. So choose engine. Right now I'm only showing Estes. I'll say show all the manufacturers. And let's sort it by engine code. So I can scroll down to E20. There it is. So there's our motor. Remember we set the manufacturer as unknown. E20, 24 millimeters, 95 millimeters long, 2-second burn time, 39.875 Newton seconds of total power, and an average thrust of 19.938. And then here's our delays. Remember we selected plugged, 0, 3, 5, and 7, and then RockSim always throws in custom. So if you don't want any of these delays, you can type in a number, and then you just hit custom, and you can type in any delay that you want. So let's choose for this rocket. Let's choose the 5 second ejection delay. Click OK. Let's see where we're launching. The parachute is going to deploy at maximum ejection delay. Starting state, we have a 48-inch launch rod. Right now we're launching straight up. launch conditions. This is, I'm not sure where this launch site is. It might be where we left off last week. I think it might be in Illinois. We'll find out really quick. And we have on our wind, if we click the wind, we have a 4-mile-an-hour wind coming out of the direction 270. So 270 is west. So the wind is coming out of the west, blowing right across the field towards the east. And if I hit flight profile, whoa! We got a problem here. What happened there? We got the motor sticking out the front end of the rocket. What did I do wrong? Yeah, look at that. It's like a Pinocchio rocket. Let me go back to engine edit. Let's see if I screwed up. Length, 95 inches. I made a 95-inch long motor that weighs 58 grams. Good job, Tim. There it is. Okay, so here's the launch visualizer from RockSim Pro. This is very much like the launch visualizer that's online, where you can see your rocket anywhere in the world. So my rocket is right down here. You got some baseball fields right there. And then if I click launch, it looks really funny. But it's going pretty straight. That's funny. Yeah. I bet you everybody's laughing. Let's see what the comments are saying while you're watching the rocket come down. Carlos, okay, is there a RockSim function that tells impact speed for the egg lofters in the audience? Okay, we can answer that one. Yeah, good question from Geekimo. Geekimo asked the question about launch lug location. Johan says, oh, that's so cool. We can get composite motors that are below 30 grams of propellant, so we can finally use e-motors in the Netherlands without permits. Black powder engines have too much propellant. Yeah. Go figure, right? Randy says you have length in inches, not in millimeters. Okay, Randy, you win the prize. You caught it before I mentioned it. Johan says, check comments when you screw up. So let me, so here's the rocket where it launched. Let me zoom in on that so you can see what that looks like. Okay, so at this point, let me turn off the smoke so we can see the rocket. Find the rocket. Let me go to this view. So this is the trajectory view. And when you're in the trajectory view, you get this button right there. And I love that button because that's find the rocket. Once it centers the rocket right in the middle of the screen, and then you can hit the plus buttons right here. You can see the rocket with its really long nose, the engine sticking out. So the beauty of RockSim is it gives you pictures, and so you can see your mistakes. All right, so that was a really good question, Johan. And the answer is yes, you can make your own motors. So you can make motors in RockSim Pro, but not the launch visualizer that's on the web, that's in the cloud. Because the reason for that is we control what motors are in there. So if you want a special motor, we would have to create it, and then everybody in the planet would have access to that motor. And I'm kind of hesitant to do that because I might make a motor like this one here, which has, obviously it's wrong, and then somebody else on the planet might use it in the launch visualizer, and then they're going to be all confused. And they're going to say, where can I get that motor from? And then they're going to ask, that's a question I don't want to answer because it's a mistake. they only ask that question for one of two reasons. One is they really want the motor. And then if I can't sell it to them, they're going to be disappointed. And the other reason they ask that question is because they already know the answer. It's a mistake. And they just want to show how smart they are by pointing out my mistakes. And that's not really fair, because I am just too easy to make fun of. I mean, it's like taking candy from a baby, because I make mistakes. Don't worry about making mistakes. All right, so okay, so that was the mistake. I made my motor 95 inches long instead of 95 millimeters long, and that's why it's hanging out the front. Yeah, so right now here's the center of gravity with the motor installed. If I pull the motor out, that center of gravity should shift rearward. Let's see if I can make this smaller. So here's the motor installed, here's the center of gravity, and if I clear that motor here, clear all, boom. So the center of gravity was here and moved back here. Because that long motor, the weight is evenly distributed, but we had so much hanging off the front that it moved the center of gravity really far forward. Normally when you put in a rocket motor, like if I choose that E12 motor, which is 3.74 inches long, it's going to move that center of gravity back. So it's currently right here without the motor installed, but when we put the motor in here, it's going to move the weight back. And so it doesn't matter what delay I said. Click. Did you see that shift? It went from there, from a bottom right here to right there. That's normally what happens. It normally doesn't go forward unless the motor is sticking out the front, and unless the motor is longer than the current location of the center of gravity. Okay, so let's click OK. All right. Okay, so another question that we had, this one came in via email. This person sent me this design. Okay, so it looks like this. Let me look at it in 3D so you can see it in 3D. Okay, so there's the rocket. Let me get a full screen of the rocket. Okay, so there's the rocket, and what he wants to do is to put fins on this tube right here. Okay, so come on, go back to where you were. Come on. If you can't get the screen to go to where he wants, go here to edit. Or is it to view? Under view, it says restored window default. And that puts it right back to where it was. For some reason, my little mouse wasn't working. Okay, so let's go back to a 2D side view right here. And he wants to add fins to this tube. And so when we go to the design components, and first let's select the tube, and you can select the tube here, but just by clicking on it. And it's this body tube. But when you click on the body tube, notice that you can't add any fins because the fins are grayed out. I can click on these all day long and nothing's happening here. So why can't we add fins to that? And the reason is because this tube right here, if you look at the icon right here, this is a normal body tube. This one right here, you notice the icon, it's different. It's showing that the tube is on the inside. So this is an inside tube, and you can't add fins to an inside tube. That's a limitation, and it was designed there by purpose. So if you have this configuration right here, how do you fix it? And the way you fix it, did I cover this last week? It seems like I remember this. Is you have to split this tube right here into two parts. This right here where my cursor is, that's where we're going to split it. So we're going to have an inside tube here to account for the weight, and then we're going to have an outside tube here where we can attach fins. I did do this last week. So what I'm going to do is I'm going to take this body tube, I'm going to edit the tube and I'm going to shorten it. So I'm going to shorten it till it gets to this length right here. And I'm going to make the length from the front of the owning part because I don't want the front to move when I change the length. So now I'm just changing the length, just moving the slider bar. You can see that the tube is getting shorter, and I'm just going to move the slider bar until come on, there we go. So this edge is right here on the end of that transition. So yeah, I'm getting real, oops, too far. So I had to make it just a little shorter than 5.445. It's still too short. 4.7. Okay, 4.7. Okay, so that's good. And it's still, let's uncheck this, that this is a motor mount, okay? And then click OK. Okay, so now we have the tube inside. Now we're going to attach another tube here on the outside, and we're going to attach it. We can't attach it to that body tube, but we can attach it to this one. So like if I click on this, you'll see that body tube is grayed out. I can't add a body tube, an external body tube, to an inside tube. You can do it the other way around. You can add an inside to an outside, but not an outside to an inside tube. But I can add it here to transition. So you can see now it's an activated button, and I click on it, and I don't remember what size tube that was. It's either a 24 or an 18. Okay, so it's not an 18 because it's too small. So let me go back to the database and say choose from the database. Let's go with a 24 millimeter. Okay, so that's right. And now it's just changing the length. And I don't remember how long he had it. I'm just going to eyeball it to where it was, where I thought it was before. Okay, so now there's the tube. And we can change the color. Change the external color to a nice bright green so we can see it. Maybe I'll change this one to red so we can see it easier. Yeah, so now you can see it. Let's see if there's anything else that we're missing. Body tube, 3 inches long, made out of paper, polished finish. And then this is our motor mount. So we can load a rocket engine into there. Click OK. So now we have this tube here. So now if we highlight it here, now I can add fins. So I'll add a fin there. It's looking in the database. Cancel that. So this is the design screen. Let me cover it up here. So we're just looking at this screen right here. We'll say it's made out of balsa, thickness of 1/8 of an inch. The location, let's say from the base of the owning part. So if I make this tube longer, it will always be attached right here to the base. And if I want to, I can slide it up along the tube, and you can look at that. See if you can even slide it over top of that transition, just like that, and it will find the edge of that transition just fine. But let's move it back to where it was, and then click OK. So now we have the fins attached, and let's go to 3D, see what it looks like. So there's the rocket in 3D with the fins attached. So that is how you do it. You have to split the tube into 2 parts, the inside part and the outside part. Okay, so you can see our inside, oops, I clicked on the wrong part. I was trying to grab this tube right there. That's the inside tube. So now you have the inside part and the external part right there. All right. Randy says, in the materials database, you have an incorrect density for one of the materials listed. Where did you get your sample of unobtainium? The density is 1/10 of what it should be. Ferengi traders? This is what I was saying before. It's like taking candy from a baby. Making fun of Tim. Okay, you made fun of Tim. Marcel. Unobtainium is not a real is not a real material. So if you go into the database, and he's saying in the materials database, so if you go to Rocket and you come down here to edit database, come over here to materials, and somewhere in here, the materials is the material unobtainium. Come on. And then scroll down. It's probably near the bottom. Urethane, unobtainium. Yeah, this is why we don't put in motors into the database that aren't real, because then people ask me about them and they're just making fun of me. But I had a good laugh too, so this is fun. We have Joe High Power Rockets from Alamogordo, New Mexico. Welcome, Joe. Marcel says, hello from work. Don't tell the boss. Okay, Mark, we won't tell the boss. We also had a question from, I think it was Carlos, via email. He asked, okay, so you're in RockSim and you design a rocket and you got it done. Is there like a checklist that you should go through before you actually go launch the rocket? Which is a really good question. So, you know, like here is the Sky Torpedo. So let's Sky Torpedo. This is, we were on this page before. Okay, so here's the Sky Torpedo. Let me open up the RockSim file for that. So let's go File, Open, right here. And it's, I'm not sure where I have it. This is a Dynastar kit. So it might be under Dynastar, Sky's Torpedo, or it's not under there. So let's go here to the S's. Sky Torpedo with a boat tail. Click open. Do I want to save that? No. Okay, so here is a Sky Torpedo that has a boat tail on it. Let's see if I have a different one. Let's go into my applications folder. Let's go to my RockSim folder. This is the normal, where normally they're stored. In your RockSim folder, there's a folder called Designs, and then there's a whole bunch of manufacturers, and like I said, this one is a Dynastar kit, and Dynastar Sky Torpedo. So click open that one. No. Okay, so here's the Sky Torpedo. This one doesn't have any decals on it, but that's okay. All right, so say you're building a kit that you bought from somewhere online. It wasn't Apogee. You didn't buy it from Apogee because we put all of our kits into RockSim. But so you bought it from somebody else and you put it into RockSim, and now you want to make sure that when you go out tomorrow and launch the real rocket, that your simulations are going to be as close as possible. So what checklist should you go through? Here's the checklist that I go through. So I go to the website, and you see right here all these dimensions and specifications. This is what I'm looking at. I want to make sure that I got the kit input into RockSim correctly. So I'm going to start looking at these things. Okay, length 27 inches. So then I come back here to RockSim. Is the length 27 inches? So to find the length, I can go here to 3D. I can go up to a 2D. And here is the length right here, 27.008 inches. Close enough. Oh, we missed up one question that was online. Let me ask that. Yeah, I missed that question. The question that Carlos also asked was, can you figure out the landing speed of an egg lofter? And the answer is yes. Where do you find that information? Well, you go here to launch simulations. You find your simulation right here. You double click on it, and it brings up the simulation details. Okay, so this right here is the summary. This is the details. So this has more information than the summary. So now we're going to look for, we're scrolling down on this page, and we're looking for landing data. Okay, so we have successful landing, time to landing, range at landing, and okay, so here is our speed, the velocity, and we're getting it in a vertical velocity, a horizontal velocity, and a magnitude. So we have vertical coming down, a horizontal going this way. Why do you have a horizontal and a vertical? Because the rocket is drifting with the wind. Because it's drifting with the wind, you have horizontal plus vertical. And the magnitude is the vector summation of these two numbers. So it's x squared plus y squared, and you take the sum of that, and then you take the square root, and you get this number right here. So you're wondering how fast it's coming down. It's right there. And so then you have to say, is that a good speed? Can my egg that's inside the rocket survive a fall at that velocity? Do I have enough cushion that it can survive? So that's the answer to that question on vertical, landing speed. Okay, so now back to our checklist. So we got the length right. Now it's our weight, 198 grams. So mass, 186 grams. So this one is a little bit lighter than the built rocket. But you're actually going to weigh your rocket after you've built it. So you'll want to go into RockSim, and then you want to adjust the weight. So now this gets into another question that people always ask is, okay, what's the best way to adjust the weight of the rocket? There are three ways. The first way is the simplest way, and that's here, go to the mass override. So up here at the top of the screen you have mass override, and it says right now it's actually using 186 grams is a mass override. And I should have seen that. It says right here, user specified. And if I uncheck this, now this is the mass that RockSim pre-calculated, 159. So that's worse. So now, what did I say? 196 grams? 198. 198. So I had to change this number to 198, and then hit tab. But you also, at the same time, you can't forget about this, because by default, this number here, this is the location of the center of gravity. Center of gravity, as you know, is the point on your rocket. I don't know if you can see me down in the corner, where I balance my rocket. So there's where it's balancing. So I would say right here, and I would measure that from the tip of the nose cone back to that point, and that length is where you have to put in RockSim, into RockSim, into this right here. And when you do it, it's without the rocket engine installed. It's everything in the rocket, all your electronics, all your parachutes, the shock cord, All of that stuff has to be in there, but not the rocket motor. The rocket motor will be added later, like at the beginning of this training session, we talked about, you know, when I put in that really long rocket engine, it moved the center of gravity because that is separate from the design. So I'm going to leave this one at, well, actually, right now it says 15.5 inches is right there. And I'm weighing it again. I was a bit further back. I was right, you know, by the P, which is, you know, I'm looking at the launch lug. I should have been like right there. So I need to make this number bigger. So I'll make it 20 inches and see where it goes. Oops, I need to check this. No, 20 inches is too far. 15? Okay, 15. Yeah, I'll leave it at 15. So that's the first way to do it. The second way is to go into all the components. So you got a nose cone. If I edit the nose cone, in the nose cone, there's also a mass override button or a tab. And you can do the same thing for the nose cone. So now you got your nose cone and you balance it, you weigh it and you balance it and you find out where its center of gravity is. And you have to check that box right here that says use the mass information below. So I don't have a scale right here, but I would weigh it, and if this would weigh 67.188 grams. And it says the CG is 4.5 inches, and I bet you that's a little bit too far forward, just based on my thing here. Okay, so that's the second way of putting in your mass or adjusting your mass. You'd have to do that for every component in the rocket. So I'm going to cancel. So I would have to do that for every one of these components. Measure the mass and its CG location. And that would give you the second way. And it's a little bit more accurate. And then the third way is to actually, instead of using a mass override, you would uncheck that. And then you would, this one says 155 grams. So this is too heavy. So before, and the mass override had 67 grams. So I would like to get that to the right mass. And to do that, you'd have to change the material or the wall thickness. Because what RockSim does is it calculates the center of gravity of every component based on the material and its volume. It multiplies the volume of the part times the density of the material, and that gives the weight. And then it will also, based on the shape, it will automatically figure out where the center of gravity is. So those are the three ways. This one here, this third way, is probably the most accurate as far as trajectory shape goes. It's not about altitude, it's about how the rocket reacts to the wind. Because what these numbers change is the moment of inertia of the rocket. The moment of inertia is a resistance to being moved. And if you have your moment of inertia right, then the simulations, when the wind hits the rocket, if you have a high moment of inertia, it doesn't want to move it. And that is going to affect the trajectory. If there's no wind, any of those three methods is going to give you the exact same result. But if you have wind that affects the trajectory, then that third method is best, but it takes a lot of work. The second and third one take a lot of work. The fast way, obviously what we did was just going to the mass override and doing it that way. This one, doing the mass override, is the fastest way, but the trajectory, if you have wind in your simulation, is going to be less accurate. Let's So it depends on how much work you want to do. That's the hard one, is the weight, diameter. My diameter is 2.6 inches. So I'm just going down here through the specifications, motor mount size, 32-inch plastic parachute. Do we have a 32-inch plastic parachute in here? Here's my parachute. Open the parachute, 32.0079, close enough. That's fine. So that is my checklist of, do I have my rocket designed correctly? And obviously, when you look at the rocket, does it look like the same rocket that you have here? That's very important too. So it's not a written checklist. It's just this checklist right here. And here is the CP. This CP came from RockSim, 22 inches. And that depends on the shape of the fins and the size of the fins. So that's going to be good enough. All right, so that was a good question too. Anything else? Johan says, with an egg rocket, extend the shock cord to the rocket with Kevlar. I had one time the egg capsule banged into the rocket real hard after ejection and ruined the rocket. Okay, so what he's talking about is nose cone snapback. You know, if you have a elastic shock cord that connects it, so this one has a Kevlar. Kevlar doesn't stretch. Elastic would stretch, so the elastic would stretch, rocket would go out and then come back and whack the top of the nose or the top of the tube and dent it. And there's a technical term in rocketry for this. It's called the Estes dent. Because Estes uses elastic shock cords and it stretches out and it comes back and it dents it. It's kind of a tongue-in-cheek thing. I'm not making fun of Estes. It goes way back. It's a long term from a long time ago. I just kind of remember it. So the advantage of elastic is you have less chance of zippering the rocket. Okay, so let me show a zipper. Okay, so here is a rocket, and if you have a Kevlar cord on it, the Kevlar cord will stretch out, elongate to the full length. But if the rocket is moving at a really high rate of speed, the tail part is still moving. It still has momentum, and it could pass the nose cone, and now the Kevlar is very taut, and it's pulling this way, and it will pull the Kevlar and zip. It'll cut a zipper down the side of the tube. That's called a zipper. You get zippers with Kevlar. You don't get that with elastic. But with elastic, you get the dent, where you don't get that with Kevlar. Typically, on a Kevlar rocket, you have to pay really close attention to the direction the rocket is going when it ejects. If the rocket is pointing downwards, that's typically where zippers occur, because you have the rocket coming down, the nose cone comes off, it slows down, this part is still coming fast, and it, this goes up, the shock cord goes up, and it just zippers the tube. So be very careful. This is a really good reason why you want to use RockSim or the launch visualizer, so you can see the direction the rocket is going when it is ejecting the parachute. Yeah. Clint Browning writes, if you have a rocket with 3 sets of fins, they don't have to line up? Question mark. Not really. Let me go back to my desktop. Let me open a design. I think there's an Estes rocket that had 3 sets of fins. Estes. No. the Lodestar is a 2-stage rocket. Okay, so here's the Lodestar. You can see it's got 2 sets of fins. These do line up. So he's asking, do these have to line up? And the answer is no. If I wanted to change these, I would edit the fin set. So let me look at it from the rear view of the rocket. Okay, so the green is the fins that we're editing right now. That's as big as I can make it. And if I go to Radial Position tab, click on that, and then I can take this slider and you'll see the green fins move around the tube. And if you like it, click OK. Just like that. So the question you might have is one way better than another? Is the fins being in line better than the fins being offset like that? And the answer is it depends on what you want. If you want low drag, then putting the fins in line would be preferred. If you want more stability, then putting the fins like this would be preferred. And the reason for that is the front fin is creating drag and it's creating turbulent flow, and by moving the other fin outside of that turbulent flow, that other fin becomes more effective. Does RockSim calculate that? No. But it will calculate the rocket's trajectory. It might show that it flies straighter. That's a good question. That's your assignment for today. Do we have a Lodestar? Yes, we have the Estes Lodestar on the Apogee website. So you can come down here, just scroll down to the bottom of the page to the RockSim file right here. The RockSim file for the Lodestar. You can actually it's already in RockSim, like I just showed you because I just opened it. It's in the design folder, in the Estes folder. You can download it to your computer and then upload it to the launch visualizer. So you have RockSim, fly it first with the fins in line, then modify it in RockSim, upload it again, change the file name so that you have 2 files. Otherwise it'll override the first Lodestar, and then see what the trajectory looks like. That's a one you can play with while we're waiting for next week to show up. Tim, hi from New Zealand, from Pyro Pedrick. He says, hi from New Zealand. In almost all of your videos, you have a Nike Hercules as a middle poster. Please, please, please show us how to get the square parts of the Hercules rocket into RockSim. The answer is you can't. RockSim doesn't allow square parts. But you can fake it in RockSim with, that transition. I used to have a Nike Hercules file in RockSim. I wonder if it's still there. Examples of complex rockets. Yep, in examples of complex rockets in that folder in your RockSim, there's a Nike Hercules. Open that. Okay, so here is the upper part. Here's the lower part. And you can see this right here, this is 4 tubes. So if I look at it from a base view, you'll see there's 4 tubes. But in real life, instead of being a ring, this blue ring right here, that's a square. So it's square here, square here, square there. But you can't do that in RockSim. And particularly what's really hard is the transition in the middle. See this transition here? It's a regular conical transition. And in real life, it goes from circular at the front to kind of a rounded off square at the back. So this design will kind of allow you to fudge it to at least get a simulation. And so this gets back to the previous question of, if you have a design and you put it into RockSim, will your simulation match real life? So then you would go through all the parameters again. Is the length right? Is the diameter right? Is the fin shape right? Does it look like the rocket? Can you get it as close as you can? It's not going to be perfect. This is what engineers do. Engineers know that you can never make anything perfect, but you can get it close enough to where the results of the simulation are going to be close enough to what it's going to be in real life. And as long as you can live with it being a little bit off, then it's okay. And in real life, it's almost never perfect. So engineers live with imperfection. This is just our nature. People always ask, what's the best? And to an engineer, there is no best. It's the most optimal. Okay. Pyropaginix says, sad. Yeah, maybe one day. Yeah, I know. I wish. The Nike Hercules is my favorite too. The poster that's usually up behind me. I took that photo myself. That was in California. There's right near San Francisco. They have a Nike Hercules museum right on the coast of the ocean where it meets the hills of California. That used to be an old Nike base, and its purpose was to defend San Francisco against a nuclear attack from the Russians or the old Soviet Union. And but the museum it's still there, and they put old Nike Hercules. They've been decommissioned, obviously, because they were in the 1960s. But the museum is there, and it was just awesome. And these were in bunkers, and when you go to the museum, the rocket was in a bunker, and then they raised it up for us. You know, they opened the clamshell doors, and they raised the rocket. It was just awesome. Yeah, I really enjoyed that trip. That was a Narcon from I don't know how many years ago. That was a lot of fun. Okay, so we've reached our time limit again. We're going to end here. Lots of good questions. Thank you, everybody, for showing up again. Thank you for all the good questions. Thank you for making fun of me. It's okay. I got thick skin. I can take it. I know that, like I said, nothing is perfect. Everything that we sell has a little bit of a flaw in it, and it drives me nuts too. And we're trying to get, perfection is here, excellence is here, and good enough is down here. And we're trying to get up to excellence and then trying to narrow the gap between excellence and perfection. We're never going to hit perfection. And every product we sell it's not quite perfect. And I always wish that I could make it a little bit better. And that's what we're doing with RockSim. We're making it a little bit better all the time. We're doing, I didn't show you some of the things that we're working on. Try out the launch visualizer, because that's like perfection, excellence, and they're like really close. What you can do in the launch visualizer to what goes on in the real world. And we're trying to make that gap as small as possible. So thanks for coming. We will be back again next Friday. Same time, 2 p.m. Mountain Time, 4 p.m. on the East Coast. Yeah, and that's it. Tomorrow we have a launch here in Colorado. They say it's going to be really windy though, and so that's kind of like, I've got a lot of rockets I want to launch, but I don't want to launch them in the wind. Yeah. So we're going to end this in 5, 4, 3, 2, 1. Go out and launch something.